So we are still on polynomials. Remainder theorem. So what does the remainder theorem says? If a polynomial function is divided by s minus 3, so that's our divisor, then the function equals the quotient times the divisor s minus 3 plus the remainder. That's what we are saying. So by the division algorithm, the function equals the quotient, that's qs, q of s, times the divisor s minus k plus the remainder. So when s equals k, so we just substitute s equals k in there. Therefore, f of k equals the quotient times k minus k, that's our divisor. So over there will be 0 plus the remainder. So f of k will be equals to the remainder. That's for the remainder theorem, right? So f of s equals remainder. So if you substitute, we get the remainder, right? Or with the remainder, if you substitute something in there, we will get an answer there, right? So let's all evaluate the remainder. When 1 f at s equals s cubed plus 2s squared plus 3s plus 1 is divided by s plus 2. So from here, we say when s equals k, then we start to k inside. The same thing we will do for here when we want to find the remainder, right? So we just solution, let s, therefore our s equals what? This, then inside it our s equals 2, right? So if our s equals 2, so in place of s, then we just substitute 2 in there. Therefore, f at 2 is what? 23. So our f of s is 23. That's our remainder, right? That's for the remainder theorem. If you substitute, you'll get an answer there. So remainder can be 0, it can be 2, it can be 3, it can be 4, it can be 5. So that's our remainder. If our remainder is 0, then it's a factor. Get this. If our remainder is 0, then it's a factor, right? So that's for the remainder theorem. So let's continue. This is our second example. So let 2s minus 1 equals 0. Let's find s. Our s is what? Half. Because when s are, so anywhere we see s, we just substitute. So therefore, our remainder is 9 on 2. 9 on 2. That's for the remainder theorem. As easy as that. So we just substitute it in there. You just make s the subject, then substitute in there, right? Equal to 0, then make s the subject, and substitute in there. Now, let's move to the factor theorem. A polynomial function has a factor s minus k if and only if f at k is 0. I said it. If and only if f at k is 0. So if you substitute and we get 0, then it's a factor. So please don't be confused with the remainder theorem and the factor. Okay, so that is when we divide f at s by s minus k, the remainder should be 0 if s minus k is a factor of the function f at s. Show that the remainder when s minus 1 is a factor of f at s equals s squared minus 3s plus 1. So they say that show that. So we can just solution, let s minus 1 equals 0. Therefore, s equals 1. Then we substitute in there. You see, if substitute in there, we get what? 0. So therefore, this is a factor, right? So always, when you substitute something, then you get 0, then it is a factor. Or when you do your polynomial division and you get the remainder as 0, then that one is a factor, right? But if you get remainder as 1, then it is a remainder theorem. Let's saw another example here. Verify that s minus 3 is a factor of the function of this. So this one, let s minus 3 equals 0. Therefore, our s equals 3. Then we just substitute anywhere we see s in the function. So f at 3. Therefore, our final answer is 0. So therefore, this is a factor. So that's for the factor theorem. So we have the remainder theorem, the factor theorem. So this one they can put together to give you a question. So they can say that the factor theorem is this, the factor is the remainder is this. So when you say the factor, just know that the factor is equal to 0. For the remainder, they will say that if the remainder of this equation is 4, then if it is silent, then the remainder 2 there is 0. So that's the factor theorem. Subscribe to Senior Police, my YouTube channel, for more videos. Thanks for watching. Bye bye.